So next test is specific gravity test. So specific gravity is a very important property, right, in the mix design process. Mix design process. If you see either a bituminous mix design or a concrete mix design, you require the specific gravity of aggregates, cement, bitumen, right, or even admixture to determine the proportions of the materials what will be adding in the mix, right. So specific gravity plays a very important role in that way, so that you can produce a proper mix. So the specific gravity is determined using different methods, right. So for aggregates, what we use for aggregates, mainly we use one is apparent specific gravity, apparent, and another is called bulk specific gravity. Bulk specific gravity. Normally, the difference between the apparent specific gravity and bulk specific gravity is the volume difference will be there. We will see what is the volume difference. Now, if we take a typical aggregate, right, the surface won't be smooth. It will be this particular shape. So now what happens when this particular solid, so this solid volume, this whole thing is solid aggregate volume, right? So this can be having pores inside, but that is not visible actually. This is basically the solid portion of aggregates. So now what happens? You want to find the bulk volume of it. So what you will do, you will dip in the water, and when you dip in the water at this particular irregularities, the water can get filled. Right? This way you can see at this particular irregularities, here the water can get filled. Now, when you determine the specific gravity, you will take only the solid volume, right? You will take only this particular solid volume. But when you find the bulk specific gravity, you will take the total bulk volume, including the volume of where the water is also filled in the this particular irregularities. This way, the apparent specific gravity, which is normally we call as GSA, and the bulk, which we call as GSB, right? So the GSA is always more than, right, or equal to GSB, or in other words, GSB is always less than or equal to GSA, because if let's say if aggregate is perfectly smooth or there is no irregularities, then what happens? This portion will be very less, and this way there won't be any difference in volume between this and this. In that case, the values may be almost similar, right? So now both the GSA and GSB, mainly the GSB is widely used in the concrete mix design, also the bituminous mixture mix design. So we will see how to find this GSB and GSA. So now basically what we do, normally if it is a coarse aggregate which is having more than let's say 6.3 mm, and some code it can also be mostly 4.7 mm seam. When the aggregate says more than 6.3 mm, so what you will do basically, you will put this aggregate, washed aggregate, in a wire basket. You place in a wire basket, right? It's a wire basket, and then we will wash it and then dip this particular wire basket in water for 24 hours. We will dip in water. So why this particular type? So that water can be observed in these kind of irregularities. So all the water goes sit in these irregularities, and then we can allow it to stay in the water for 24 hours. So of 24 hours, what we will do? We will first determine one, weight in water. That means without removing the aggregates in air, we will find the weight of this particular wire basket plus aggregate in water itself. It is a submerged weight. Then we will find weight in SSD condition. Now SSD means saturated surface dry. So this is what is called as SSD condition. SSD means the aggregates, the water of aggregate won't be dripping, but they are still wet. So the water will not drip, and but they are still wet. So we will find the SSD weight, and then after this SSD weight, we will find weight in oven dry condition. oven dry condition. So once we find these two particular weight, what we will do? We will keep the aggregates in an oven at 110 degrees for 24 hours and then find the oven dry weight. Now with these three weight measurements, we can find GSA and GSB. Basically GSA, that is apparent specific gravity. Basically what? We will take oven dry weight, right? This weight in oven dry condition divided by, right? This is weight in oven dry minus weight in water. So this will basically give, if you see why we are taking weight in oven dry condition. That means this particular weight is taking only solid mass. It's not considering the water which was there in the aggregate. So the weight in water minus weight in oven dry condition minus weight in water gives you the volume of the solid aggregates. So we get this particular measurement. Then we have GSB. Now GSB will be equal to weight in oven dry condition divided by, now in the GSB we will take the whole bulk volume. So what we will do? We will take weight in SSD, right, minus weight in water. Now since this particular denominator value is more, right, since though the weight are similar in both GSA and GSB, since the denominator here is less and denominator here is more, because the weight in oven dry condition is always less than weight in SSD, right? So what I can say, this particular value will be more, so the GSB value will be less, and similarly this particular value will be less, hence the denominator will be low and GSC will be always high. This is how we find the GSA and GSA and GSB.